15-1. Here we go. We talk about proportions, population proportions and whatnot, and testing hypotheses dealing with that. And the book gives you some great examples. It talks about what would be the possibility if I don't know, they have them there on page 534. General Motors reports that 70% of leased vehicles are returned with less than 36,000. A recent sample of 200 vehicles showed they had less than 36,000 miles as the proportion increased. And so you can kind of look at those ideas or those samples and give you an idea of what it is we're doing here. Now, for problem number 1 here, it just gives us the basics, right? It states the hypothesis. It says that what do we call that? Pi is less than, I don't have it written up here, but the hypothesis is that pi is less than or equal to 0.7, and h sub 1 is that pi is greater than 0.7. So the null hypothesis is that it's less than or equal to, and the alternate hypothesis is that it's greater than 0.7. So then it says a sample of 100 observations revealed that p, or proportion, is equal to 0.75, so higher, than what we're looking at in terms of the null and the alternate hypothesis, right? So at the 0.05 significance level, can the null hypothesis be rejected? State the decision rule. So first we have to find our critical z. And again, we can look at our chart in the back, or we can come here, and we got the 0.05, and so we could do it this way actually. What that's telling us, and if we look at the alternate hypothesis, that's one I always look at, that it's greater than 0.7, and so in this case it's going to be, I'm going to reject it if my answer is greater than, and I come up here where I'm watching the percentages, and so I got 0.5, and so I want 90.05, right? So I want 95%. Okay, I'm pretty close, 1.64, and actually kind of, there we go. So 1.64, it's between 1.64 and 1.65, exactly between those. And so I can say, and I don't know if ours in the back of the book, maybe it's a little more definite, but the critical z then is at greater than 1.645. So my decision rule is that h sub o, or my null hypothesis, which I should have put in there, but it's in the book. So the null hypothesis is rejected if my z value is greater than 1.645. Now the formula, and it's one of those kind of gnarly looking ones that's really, really easy, is just simply this. It's that p minus my pi, so my proportion that I have minus my pi, divided by the square root of pi times 1 minus pi, divided by n, or the number in the sample, which is given in the problem, right? So I broke this down. I said, well, the top part of it's just going to be equal to my p minus my pi. I know my language just sounds weird, doesn't it? And then I've got the pi times 1 minus pi divided by n, so I've got that included in here, so it's simply equal to my pi times parentheses 1 minus pi. I don't know who laid awake nights to come up with all these formulas and whatnot, divided by my n, gives me that, and then I have to take the square root of that, and that's just for the bottom part, and this is going to be the square root here, so equal to the square root, and that's what I have, so the square root of that, and I end up with 0.045, and now I got to divide this by this, so my 0.05, my 2 that I have in peach is the color, I'll call that. So it's equal to that divided by that one, and I come up with 1.09. And my critical, my decision rule was that the null hypothesis is rejected if my z, my calculated z, is greater than 1.645, and it's not. Okay, it comes to 1.09, so I cannot reject the null. I cannot reject the null. So it's very possible then that my that the null hypothesis, that my sample size could be less than 70% as opposed to the 75 that I actually got. So there you have 15-1.